Hello and welcome to Between Two Servers, the show about netcode and game development for game developers. I'm here today with Jacob and Barry from CableLabs.com. Check this video out and see what they do.
Let's be honest, we all love being connected. Streaming, binging, gaming. Access to internet makes every part of our lives go round. It provides the foundation for, well, everything. Working in our modern economy, entertaining our kiddos, even falling in love. And this is all possible because of our research labs tucked away in Colorado and California. Hi, we're CableLabs. From DOCSYS and the fiber infrastructure which delivers internet and TV to homes and businesses across the world, to the future 5G service you will enjoy in your smart car. In fact, over 500 million people around the globe use our technologies every day, maybe even a few in your own home. Our researchers invent solutions and our ecosystem brings it to you. We collaborate within and beyond our walls to define the future. We work with universities, startups, suppliers, and our member base. The end result? You get faster and responsive internet, quicker Wi-Fi, and the ability to stream the shows you love. How we live, work, learn, and play will continue to evolve and become more seamless. At CableLabs, we connect the world so you can connect with yours.
All right, now that we know a little bit about what CableLabs is, Jacob and Barry, can you tell me, what do you guys do and how is it relevant to game developers out there?
CableLabs is an award-winning innovation and R&D lab for the cable industry. So our members, our customers, so to speak, are cable companies and mobile network operators from across the globe. The technologies that have been developed at CableLabs are deployed in cable networks and mobile networks, that these members manage. The team that Barry and I are specifically a part of, we're part of this product strategy group at CableLabs, and we're a highly user-centric group, fast-paced. Part of the team focuses on kind of doing primary market research and kind of understanding kind of what users are saying that they'd like in future products and services. The other part, which I work on, is kind of more of empirical research on kind of studying how the network's being used and kind of how that's evolving over time. And then Barry represents a function of the group that focuses a lot on kind of ecosystem development and kind of fostering engagement on that front, of which the gaming and game developer community has been a very highly prioritized focus of the group. Barry, I don't know if there's anything you wanted to add.
Yeah, just a couple of things. First of all, the gamers are, we frame them as power users and as high value customers. They're always demanding more from us and have very busy networks. Some of the studies we've done show that if there's a gaming console or PC in the household, you've got 2 times the traffic taking place in that household. So you're always putting stress on the on the network. And I think we've turned the corner on that, because when I first started evangelizing, some of the low latency work we've done, and specifically targeting, the gamer segment, we did get some stuff about, it's pimply-faced 17-year-old in the basement on their parents' dollar. So we quickly got rid of that that stuff and opened their eyes and said, these are the guys who are paying the money, right? If you can improve my gaming experience, there is money in it for you. So, and gamers are also talkers, right? I mean, they very socially engaged. One other thing on CableLabs, we have 65 of some of the world's largest ISPs involved here. And as we said, it's PON, it's cellular, of course, the DOCSYS, the original cable networks, but also do a lot with Wi-Fi, because guess what? 85% of connections for mobile phones get backhauled over somebody's.
So even though I'm actually cellular, I'm going to a node that actually has to Wi-Fi back to a wired network. Is that true, Barry?
For many people, they drop back to Wi-Fi as soon as they walk in the house, walk in their business, walk in a place, and that when you actually look at the data analysis, it's held actually fairly steady, around 80 to 85% of what you do on your phone is not going cellular. It's going Wi-Fi to a fixed line network.
It's literally that Wi-Fi is just by usage 85% of the connectivity on these devices within the home. Interesting.
That's correct.
Okay.
And that's the telcos have been getting a free ride, on the backs of the fixed line operators for quite a while. That's why our operators who are actually connecting to Wi-Fi, who are either MNOs or MVNOs, can actually provide better network connectivity across the board, because they don't want to go over cellular because it costs them more money than going over a fixed line backbone.
Makes perfect sense. So CableLabs, it's a standards organization. It's a non-profit. You've mentioned other things like PON, which is passive optical network. Is that correct?
Yep.
Wi-Fi standards, and DOCSYS, which is over the coax. Is CableLabs.com just cables? What's the story?
As I mentioned and Barry touched on, even though you might have kind of historical perspective for membership in cable or HFC networking, which I think we'll talk about a little bit more in the details of, later on in the show, our members deploy and manage a variety of networks. And a lot of that is determined based on, kind of what would offer kind of the best experiences in the product and services space, regardless of kind of what that is. Some of that is still kind of in HFC and more traditional kind of cable networking. Some of that is in offering fiber to the home services. Some of that is also in offering mobile coverage, over more traditional kind of, cellular kind of handset plays as well. So, since our members operate in a lot of different aspects of the telecommunications industry, we at CableLabs do a lot more than just cable itself.
So your members are ISPs?
Yeah. So, for example, Barry mentioned on this earlier, but just to kind of level set on kind of the types of companies we're talking about, some of our members are companies like Comcast and Charter and Cox here in the United States, Rogers and Shaw in Canada, Liberty Global out in Europe, NBN down in Australia. So a lot of these are kind of...
So you are, in fact, worldwide and not just limited to coaxial in the United States.
JCOM,
yeah.
Yep.
Awesome. Okay. So what's in the name? Why are you guys called CableLabs if you're not... I know you have some labs.
Yeah.
But you're much more than just cable. What's the history of the name CableLabs? Where did that come from?
It goes back to a very unique aspect of the cable industry itself. The cable industry has been a very collaboratively working group of companies historically, ever since the early days. In the late 1980s, there was a guy by the name of John Malone and a few of the other kind of early pioneers of kind of the early cable companies that created CableLabs. In some ways, we were very similar to kind of what Bell did for the telcos at certain points in time over history. So because of the early days, that's where cable came from. CableLabs is actually an abbreviated version of Cable Television Laboratories. So because of the early days and kind of the network technologies that they were using, that's where the name came from. And given that there were a lot of these companies operated in kind of local regions across the United States and North America, there was benefit in kind of being able to kind of coordinate and drive kind of consistency in the network technologies that were being used, the hardware that was going to be developed by the vendor community, how people were going to deploy kind of assets and things on the network that allowed them to have kind of greater scale and kind of ability to kind of just be kind of more economically kind of viable and consistent. And so that was kind of where a lot of the research and development came from. It's one of the reasons why we're a nonprofit. So we don't sell any products or services on the open market. We operate under kind of this model where all of the innovation work, all of the research and development work that goes on network technology, be it Wi-Fi, PON, or DOCSYS, gets shared broadly across our memberships for them to deploy, incorporate in their companies.
So you guys effectively create the standards, and your members deploy the standards when they're building their own networks, so that they're using a standardized system.
And for the vendors, this is very beneficial as well. So it means that basically their addressable market is much larger, because everybody, you can differentiate, we do enough, you can differentiate around it, but that was a critical piece, because with all these somewhat fragmented, a lot of these guys, to be honest, starting were were family-owned businesses in the U.S. starting up around originally. So being able to provide that, to a vendor community that says, "Oh wow, I've got scale now. I can develop chips."
If you build to the standards that you guys are creating, all of your members can use them, and they may select vendors and build their networks with the best implementation. And as a game developer, someone's playing on a cable modem. They're definitely using your standards. Someone's playing over Wi-Fi. They're definitely using your standards. Is that correct?
So things like Wi-Fi, those are typically kind of led, kind of by other kind of industry groups within the telecommunications industry.
So like Wi-Fi 6 and so on and all that stuff?
Yeah, so the Wi-Fi Alliance. And,
Wi-Fi Alliance is a great
okay.
example of one. 3GPP, IETF, all of these other kind of...
So is Wi-Fi Alliance almost like a Wi-Fi specific? Like, should I call them Wi-Fi Labs?
Yeah, I guess in some ways you could maybe think about it that way. But they have a variety of members that participate, and CableLabs is one of the participating companies.
And we not just participate, but we work with a lot of standards bodies.
Yeah.
And we contribute. We want to make sure that our members have early access to the best technology. But these days, if you're not paying attention to standards, you're doing something wrong. It's very important. So, and as Jacob said, we've developed a lot of patent pools which are shared among our customers. In the early days, when video was becoming digitized, we have a lot of MPEG patents. Okay, so that meant our members using MPEG
we're
did
talking
not
like
have to pay
80s
those
here?
royalties.
Is this like back to the 80s?
But that was back in the 80s and the
Wow.
early 90s. So, yeah.
That's amazing. So all of the old cable was delivered over coax. Tell me a bit about how this started transitioning late 80s, early 90s into data networks.
Yeah, it's the history of cable is actually, I think it's pretty interesting, and especially as I've learned more about it, I think the early origins are something that a lot of us can relate to. We wanted, there was a desire to be able to watch video and have entertainment at home, and in rural America where there's a lot of trees and a lot of hills, a lot of over-the-air kind of technologies didn't work so great. So there was this idea of, what if we just kind of go to the top of stuff that's really tall, put up a big antenna, and then we create these networks to deliver it out to the people that live in the surrounding areas. So you think about places like, rural Arkansas, rural West Virginia. That's where a lot of the kind of the bread and butter of the early cable industry happened. Over time, as you can imagine, there was a lot of evolution there, and coax was the backbone network that made a lot of this possible. Early set-top boxes, companies like HBO and being able to provide kind of premium services, being able to build encryption onto the network and being able to know that, Glenn is subscribing to this and Barry was subscribing to this. These were technologies and innovations that had to be deployed over time.
Okay, so now you've got a tiny little upstream of control data. And a huge stream down of video.
Yeah, so the very interesting thing in the 90s was that there was a desire for things called pay-per-view and video on demand, where for the first time, Barry might want to watch something at his house and he needs to signal that back into the video provider. Say, hey, I want to watch this asset or buy this asset and be able to watch it in my home. There's also this other two-way thing that we enjoy doing these days called the internet. And so once we had the
never heard of it.
Yeah, we couldn't be using it now or anything. Once we had that upstream channel back, it allowed us to start thinking more creatively about how the network could be used. And so the network that we have now was, really founded in, a video delivery network that started to have data services added over on the edges of the spectrum and things like that. It's also one of the reasons why the network today has historically been very asymmetric. Video is a very downstream heavy activity.
I've always wondered that. So what is the exact technical reason? Is it just that it was built out for this asymmetrical delivery?
Well, there's a couple of reasons. Part of it is founded in kind of the way that video is, the things that we're doing right now, and when we watch Netflix at home or YouTube at home, those are very downstream dominant things. And historically, if you look at how the internet's been used, it's been primarily driven by a lot of that type of evolution and innovation on the network. And so there's just been a very light upstream component. We as people as subscribers on the internet, we also don't produce a ton of volume to push back. And so, historically, there hasn't been a huge demand or need for kind of symmetric services. Although that's kind of changing, we just are on the tail end of kind of, 2 years.
We're Zooming right now, and we have an upload of video.
Yeah, we're doing right now. And the things that we're doing, remote productivity, work, hybrid work, school from home, all of a sudden, there's been, a greater demand for upstream. And that's one of the reasons why we've started to see the industry change, and some of the technologies I think we'll talk about a little bit later on kind of what CableLabs and the industry is doing to kind of make that a reality for, customers across the globe.
Okay, this is cool. So basically we've got a historical reason and also just a huge usage pattern as to why there is that asymmetry, at least in the United States. It isn't so much around the world. Like, I tend to look at a lot of other more recently built out stuff, and like Korea. Korea's typically more symmetrical. Is that true? Or is it just because they built it out that way?
I'm not super familiar. I'm not an expert on, Korean, internet traffic, but I will say,
the Korean internet is basically a LAN.
Yeah. And it's a lot of that.
It's the best in the world, basically.
Yeah, and I know that there's a lot of, and I think one thing that you're touching on too is that, the way that the internet gets used in different parts of the globe is, it can be unique. The United States was a leader for a long time in over-the-top video maturation from that market. And it's taken time for other countries around the world to really
relatively a very large country, and also Australia. Very large country, very difficult to get.
When you, that's one of North America's challenges. Has always been there. Is if I'm in Korea, highly dense. If I'm in Japan, highly dense. Build outs are a lot cheaper. And if you look at, and that was the same with mobile phones, right? Why were we late on mobile phones? So the geography plays a big part, and the architecture of networks. The old telco networks in Europe were much closer. There were small central offices. Here were big central offices dragging out. So that's always something one needs to think about. And that's one of the reasons with cable, this is all about usage of spectrum. We said we're going to allocate this much spectrum to upstream, this much to downstream, because that's what users need.
So you're just matching the usage pattern.
Yep, and it was efficient. It was for efficiency, right? I mean, it's just it's what you do in a business, right? You look at efficiency. When COVID hit, and we had 30% jump in upstream traffic in a couple of months. One of the things that was really interesting was how resilient the network was, and how, although there were a few burps, most people look at it and saying, "Wow, that went pretty good." All that traffic that used to be in business is now running from home over cable, as opposed to running from a dedicated fiber, and that shows you the power of the networks that our members have in place.
Awesome. So let's talk a little bit about how these networks are built. So although, we're talking CableLabs and coax being sort of a bread and butter here, the reality is that these networks are basically 95% plus fiber optic. How does this work? Where does coax come in?
Sure. So if we kind of go back to the early days, kind of going back to what we were talking about a moment ago, they were largely purely coax networks. Over time, though, there's been this dynamic in our industry that's called kind of pushing fiber deeper. So what that means is that over time, as more bandwidth has been needed kind of closer and closer to the user home, fiber optics have been deployed. And so in today's world, what we typically find is, in more or less, kind of think about it in your neighborhood, you probably will have something that's called a fiber node. And the fiber node is a very important aspect of an HFC network, which the HFC
What does it look like? Yeah, is it like a little building, or is it just like a little box somewhere?
So in my neighborhood, I actually know where mine is. It's kind of right there, one house down, and it's a green little pedestal thing. It's maybe just a few feet wide.
Oh, I think I've seen those in Santa Monica when I used to live there.
Yeah, and so those are fiber nodes. And what it is that it has a device that takes fiber optics on one side, and on the other side, it starts the coax network, which is the distribution network that runs out to everybody's houses. And so there's taps of coax that run out, and that's the jack that goes on the side of your house and what activates the coax ports on the inside of the walls of your home. And so those fiber nodes are very important, and depending on how long the coax runs, there could be amplifiers to kind of boost the signal.
So are those fiber nodes like for like one operator or for like a bunch, or how does it work? Is it different everywhere?
So the fiber nodes are typically used by individual cable companies. So for example, here in the metro area, we are Comcast/Xfinity market. So Comcast owns the fiber nodes, and they don't share that asset with other companies. So the telco company, for instance, when they deliver DSL or if they're offering fiber services, they would have a separate network that they utilize. And the word that you may hear sometimes in talking about kind of network build-outs called overbuilding is the idea of kind of building multiple networks in the same spot, and the economics and kind of engineering behind that. So
okay, so we hear terms like fiber to the node, and then we hear terms like fiber to the home. Yep. So really the difference is just instead of coax, it's fiber from the node to the house.
Yep.
Got it.
At some point, you've got to convert from the photonics to some electromagnetic spectrum, right? And so it depends where it does. Since we have this stuff in place, the economic, digging trenches and pulling new cable is always expensive, right? And so that's why, when you start looking at the cost of, homes passed with a fiber network, it gets pretty big, especially if you've got a trench. But the thing is, the cable guys already have this in place.
So here's where the standards that CableLabs develops come in, because you are the creators of the DOCSYS standard, which is the standard over coax from the node to the home. Is that correct?
Right.
Yeah, so DOCSYS is basically
and the modem protocol. And the modem as well. Okay.
Yeah, so DOCSYS is that protocol that sits on top of an HFC network, which the HFC
data over cable interface specifications. Okay, so this is when we transitioned from the analog video, linear video delivery, and added internet. This was the big thing around 1999, 2000, when DSLs were getting out, and there was a lot of people making choices about how you did it. But for the cable industry, since we had owned a lot of customers, owned access to the home, just like the telcos did with their twisted pair for DSL. This was a massive new business, and with a strong demand.
You guys have been doing something really interesting, which is why I've been full disclosure. I've been working with you guys for years. We've been chatting pre-COVID, and it's all because of one really interesting thing you're working on, which is the more recent DOCSYS standard work that you folks have been doing around dual Q. Who would like to explain this one? I think it's really interesting.
Barry, why don't I can maybe set up kind of how DOCSYS technologies have evolved over time, and then you want to talk about low latency a little bit more specifically, since I think you're more familiar with it. There's different generations of DOCSYS technology. So it started with DOCSYS 1, and right now the most widely deployed version of it is DOCSYS 3.1. So they're currently we're in between generations, so to speak, right now. So DOCSYS 3.1 is currently kind of active in the field. If you see in the news, some of the largest cable companies have mentioned that they're going to start being able to offer, multi-hundred megabit per second upstream. That's a byproduct of the technology that's incorporated and embedded in DOCSYS 3.1. So to give people an idea of kind of what levels of speeds we're talking about, if you're running a DOCSYS 3.1 network with, say, like a high split, you could still have the same, gigabit, 2 gigabit per second downstream speeds that we see in the market already, but you would be able to be in kind of the multi-hundred megabit per second range on the upstream side. And we believe that if deployed and kind of architected the right way, you could potentially push gig symmetric over those networks. The next generation is DOCSYS 4.0. And so the 10G platform that the cable operators have been speaking about, DOCSYS 4.0 is a key core of
What's the time frame for 4.0? Is this coming soon?
So 4.0 will be a set of technologies that will be getting to be deployed over the next few years and kind of in the years after that. So one of the things is that at CableLabs, we don't know or really kind of make a decision on when technologies are deployed. That's up to all of our companies. So that's up to all of our members rather. But in DOCSYS 4.0, that's where we will see kind of multi-gigabit capacity on the network.
On the coax portion in particular, being able to support that. And then the backhaul could be, it could be a different story, right?
Yes, so on the backhaul. Yep, exactly
okay.
right. And so the low latency technologies that you're talking about, and I'll let Barry talk about this, it is something that is available on DOCSYS 3.1 networks and will be an integral part of DOCSYS 4.0. And it's a complete evolution in the way that the industry has thought about latency. And Barry, I don't know if you want to talk a little bit more about kind of the technology itself and the innovations that it brings.
One of the things we believe is that in future networks, milliseconds are going to be more important than megabytes, right? This is, and gamers have been there for a long time, right? Gamers, they're always leading and pushing the edges of the market, which is one of the reasons I like working on gaming things. But that aside, so one of the things we did is we started looking at, early VR stuff and what would it take and, what kind of bandwidth was going to use. Because one of the things we do for the industry is help track bandwidth and growths. So it's one of the things that Jacob's team has done for a while, to try and make sure we inform the industry. So we started looking at, at VR, and this was, it's too early. That's not going to be mass market. And I had just started fairly recently, and I said, but gaming's mass market, and it's latency sensitive. Let's grab onto it. Let's look at let's look at what this is and do the analysis, because I think all the gamers out there know that latency is a combination. There's a whole latency stack that goes on from pressing buttons on a game controller or a mouse, all the way back to the server. So we started looking and said, okay, these are all additive latencies. Let's look at what we can have control over, i.e. the access network, which is it's often called the bottleneck network, because it's where you're actually provisioning to a certain data rate, right? So so we started looking at it. We started looking at traditional multiplayer games, non-online games, and characterizing the data flow. Oh, gee, really small packets, 30 to 60 times a second.
Amen. Yeah, less than a megabit down, maybe 256 up.
Yeah, it's not bandwidth. The bandwidth pain is on downloads, not on gaming. So why is it so bad? Right? And so one of the things we, as we did the analysis, we said it's bad because TCP congestion control is terrible. What happens is you're gaming and somebody, starts uploading something from a camera. You get a download. You get a Netflix download coming down, and what happens is all these little packets get stuck behind this bulk of packets.
Yeah, you get this guy.
You get this sawtooth that's buffer bloat, and actually in 3.1 we'd already done some work with something called AQM to help with buffer bloat, but it really didn't help jitter very much. One of the things we realized was that average latencies are good, and you want those.
Yeah, average is lying. I've seen this with people with my company. My average latency is fine. Why is everyone complaining?
That's
right? It's consistency as well.
It's the variable latency that's getting you. And we talked to gamers and drew this line saying, oh, by the way, you got twice the amount of traffic in your house as somebody who's a non-gamer, so of course you're more sensitive to this stuff. So what we did was we actually separated things into, looked at traffic patterns. So a lot of people try and fix this with quality of service, say, oh, we're going to save this bandwidth for you. Say, no, we're just using the bandwidth inefficiently. So what we did was we set it up so that we could separate the sparse traffic, status packets going up and down from the bulk traffic, and basically give them a dual queue. The classic queue, which is what we're running now, and we added a low latency queue. Yeah, that's right.
So they're separate, and there's stuff reserved for this latency sensitive small portion of traffic.
Right, and actually it's not even reserved. We actually don't change the amount of bandwidth. The low latency traffic, when we redirect it in this queue, we just let it out first, doesn't affect the bulk traffic. It has no perceivable effect.
It's just that I'm not getting stuck behind the bulk stuff.
That's correct. And this is something we had to talk to the regulators about, and saying, this is not a zero-sum game. We're not stealing from these guys to do these guys. We're doing better traffic management.
Yeah.
But the games need to declare the fact that they have a certain pattern of traffic, and we're using actually diff serve points for this, DiffServ packet marking, which is actually available in a lot of platforms. It hasn't been. It's normally not been used within LAN situations like home access.
So we also I believe that my company does the tagging that you're talking about.
Yes,
and we just set the TOS bit to a real-time class, and that's the thing that basically signals to the cable modem only up to the node. That it's that.
Only
help
up,
me
yeah,
understand
so
what it's doing.
Yeah, it takes you actually beyond the node. So when you go through the network, you have nodes. Optical nodes for splitting fiber, and then you get up to what's called the CMTS. And DSL talk, the head end. It's but
so
basically
that would be like one
Wilshire
in LA. So you're getting me all the way from my home over coax, and then all the way over the fiber, potentially in a more latency efficient way that's not going to be subject to being behind. So you're fixing the last mile problem for real time.
So we're fixing that last mile problem, and then most operators are pretty efficient. There's all these segments. I mean, you guys do the middle haul. Once you leave the operator network, you're making sure that you're doing appropriate routing, because that's the routing problem.
This is what Network Next does. They're not doing a great job, but I'll tell you that it can be fixed, so it's okay. But the thing that I can't fix is that last mile.
You need to fix.
Yeah,
it's the last mile.
This is fantastic.
And the other thing that's interesting about this is that if you set these markings, most access points will actually map Wi-Fi, wireless multimedia, QoS markings between DiffServ. So one of the things we've done, we went and talked to companies, we were evangelizing this with folks like you, and one of the things we were able to say was, well, by the way, it's not quite deployed yet on the DOCSYS networks, but you'll get Wi-Fi benefit now.
Okay. So I'm a gamer. I'm a gamer over Wi-Fi, and I'm using a game that tags packets in this way. I'm getting benefits to my Wi-Fi access point in terms of prioritization of my real-time traffic over bulk traffic. And this is typically a horribly congested, noisy scenario.
It's always noisy, and the thing is, they're these small little packets. They make no difference to the other guys. You're not hurting any of the other traffic that's taking place. You're just assuring that your packets get appropriate traffic management and routed.
This is amazing. So long story short, if you're making a game, and I know a lot of people who watch this show are game developers who make multiplayer games, you should be tagging your game's traffic. Now, is it just in the upstream? Should you be tagging it on the way up to the server only? Should the server? I know the server sending it back down will kind of be like off the middle mile. It's not really gonna. So I think is it just that the uplink needs to get tagged?
So
what's the best practice?
You get value on both sides, right?
Okay.
One of the troubles is if you were transiting the generic internet, most of those packets.
No one's going to hold on to that TOS bit passing over the middle mile. They're going to strip it.
Exactly. So in the initial phase of this, we'll see most of the benefit there. On the other hand, if you're, if a lot of we've talked to a lot of the game platforms and the game engine guys and other people doing netcode stacks, and they're discussing with our members, well, we're peering with you anyway, can we preserve those bits across the peering point? Right?
That's really smart.
There's a number of ways to manage this, but one of the things you do is you'll immediately get the upstream. You get Wi-Fi, you get Wi-Fi benefits, and you'll get the DOCSYS benefits when our members start doing a full rollout of the low latency DOCSYS, which, by the way, it's a software upgrade to the modem. It's just a quick download to upgrade the modem. So
that's awesome. So Barry, I'm gonna put my little black hat on, okay, and I'm gonna go, wow, I got this prioritization thing from CableLabs, and it's awesome. I'm gonna DDoS somebody with it, or I'm gonna tag everything. It's not a problem, is it?
No, because we actually put some protection in place. One of the, having worked with gamers, one of the first things you think is, if I provide some mechanism, somebody's going to abuse it or just test it, right? It's why the world's so much fun. So what we have actually put queue protection in. So what we do is we watch effectively when you tag this bit, the application, in this case the gaming application, says, oh gee, I'm gonna give you this kind of traffic, so please put me in the low latency queue. So we do. But then we watch every packet. And if what you do is, if they're large packets that are going to overflow it, if your pace isn't right, queue protection will kick in and we'll kick you back to the classic queue. Okay.
That's amazing.
So if it's, because
so
to
if
be
I
honest,
abuse it,
you
I don't
wouldn't
get any benefit from it.
Yeah, and you wouldn't, and even if you used it, you wouldn't get any benefit, but you'd hurt other people. So what we wanted to make sure was that that you didn't hurt other people, and that part of the traffic management was this queue protection, saying, okay, we're keeping track all this time anyway. We're going to look and say, oh, you just slipped outside of the profile.
So effectively, I would be sending too much, and then across the shared last mile to the node, there would be some, whoa, actually, no, that doesn't quite fit the profile. Regular stuff for you.
And if it's normal, kind of like traditional kind of queue building traffic, the classic queue that Barry referred to earlier.
Works fine already. Yeah.
It works fine already, and there really is no benefit of kind of using this classification. It's only on these kind of latency sensitive flows.
So we're talking about time sensitive time series data over UDP. Basically,
one of the tests we were first looking at latency was we took a web page which is just full of DNS calls, and links, and all this very lightweight traffic that is waiting for responses back. And one of the things is that for those, the load of a web page levels out no matter how much bandwidth you put in. There's a point where you can't do anymore because the latency kicks in. But if you do, but if you say, well, what happens if I reduce latency? Suddenly your page load starts going up. Same amount of traffic. It's just that you are now in a queue that's not getting blocked by all this other stuff that's going on. So there's long term, there's other things, but gaming is absolutely the one. And actually, even for things like cloud gaming, you want to do it for your input, because input delay is a big thing there. So if you do it just on the input side, you will have improved performance. Work at home, sharing a screen. Anytime you've shared screen and you hit a button and hit a tab and nothing happens. So you hit it twice and suddenly you got 4 screens up. So, but gaming is the one who benefits most from it.
Cynical time. How do I know that it works? Jacob, I think we've got something really cool to share. So we can announce this today. So we were able to, as a partnership between Network Next and CableLabs, we were able to share anonymized data with them. And Jacob, you did something with that I was surprised and actually extremely impressed to see, which is it was an accidental A/B test with and without the DOCSYS tagging. And it proved that it worked on a real live game.
Before I kind of get into the collaboration that we had, while we were talking about low latency stuff, I also just want to give a shout out to some of our colleagues at CableLabs that have been very instrumental in developing this technology. Because Barry and I, we're working on the strategy side. We interface with kind of the ecosystems and stuff like that. But like Greg White, Karthik Sundararajan, and Steve Glennon. I mean, these are a lot of the core technologists and engineers that put a lot of expertise and time and energy into creating the solution and advocating it.
And passion, I got to say, passion.
And they did a lot of the grunt work. In the industry groups to convince other, kind of industry partners that this is something that's worthwhile, and to convince them of the technologies that have been created. So I just want to make sure that they get recognized as we're kind of talking about kind of the innovations and technologies here on these cable networks.
As well as taking things to the IETF, this queue building, non-queue building it will hopefully be an RFC within a month.
That's brilliant.
So we're, again, this is for the benefit of network in general. We really believe, we believe that we can make the internet better.
Yeah.
And as I get to one last thing, and I love the comment that Barry made. The passion is that we're passionate about the technologies and the innovations that we produce because of the impact that they have on lowering latency, making more reliable networks, offering faster speeds and capacities to enable next generation stuff. And, the game developer community is a huge driver of kind of, providing great user experiences to people all across the globe, and being able to have networks that can support and do the things that they want to do is something that, we're consumers ourselves, and so we'll eventually be able to enjoy these solutions as well. But getting to what you were mentioning, Glenn, In the partnership that we had when we were doing this collaborative work, in the slice of time that you did, there were a few of the platforms that you had enabled the marking on, in particular Switch and also the Windows platforms, and then the PlayStation,
but not on PlayStation and not on Xbox, I think. Yeah.
And so what we were able to do is on the Wi-Fi side,
not by design.
Yeah,
we just didn't get it done in time.
Yeah, I remember we were just like asking about, hey, have you been doing any of the marking? And then you mentioned it, and then we turned around and, Barry and some of the other folks at CableLabs were like, wait, we might be able to do like a very kind of exact matching exercise here.
Oh, yeah.
And so what we were able to do is on the Wi-Fi side, we were comparing some of the Wi-Fi kind of queuing delay and latencies that we were seeing. And going back to Greg, Karthik, and Steve, they were very instrumental in providing feedback on how we could work with your data to kind of back out and get as close as we could to identifying kind of what Wi-Fi was contributing to kind of the latency piece itself. And what we found is if we kind of use PlayStation as our baseline case, if you look at kind of 99th percentile queuing delay inside the home, we saw a 23% improvement from the WMM marking on Windows and a 46% improvement on the Switch platform, which is substantial. And I want to also emphasize and go back to something that we mentioned we didn't touch on earlier as it relates to Wi-Fi, is that Wi-Fi is massively popular with the gaming community. For perspective, in the data set that we worked on together, every single platform had more Wi-Fi players except for Windows than wired. On Xbox and PlayStation, it was about 2-to-1 ratio that was Wi-Fi versus wired. Switch is all wireless unless you buy the little Ethernet USB dongle, right? And nobody does it. I think out of the universe that we had, it was like literally like a dozen people had like the Switch Ethernet thing. And then for Windows, there was marginally more wired players. So being able to have improvements today on gaming traffic for your Wi-Fi customers is substantial and will be immediately noticeable because so many people, and I know Barry was involved with a lot of the market research that we were doing, and people coming from a variety of places. Sometimes you're a teenager and just need to be able to play in your bedroom and you don't have the capability of running an Ethernet cable there. Or you have roommates and you might be moving a console between the living room and your bedroom as you need to share communal space.
Playing from a laptop. I mean, it's just the world we're in 2022,
Consoles don't ship with Ethernet cables. We looked at it. PC towers have the highest penetration of Ethernet.
Okay.
Laptops were next. Right, but they were much more Wi-Fi. I mean, it all just makes sense, right? Mobile devices, and so when we first looked, I must admit, I was a little surprised at the at the amount of Wi-Fi penetration there was. But this is the world, so let's fix it.
So we actually track whether someone's connected over Wi-Fi or Ethernet in our SDK. So that's how we can actually get that data. And obviously, we see that in general there's higher jitter. There's not really noticeably higher latency so much, not significant on Wi-Fi, but it definitely is higher on jitter and somewhat higher on packet loss.
And Glenn, you might see this on your side, but it's like when Wi-Fi goes bad, Wi-Fi can go really bad, and there can be more delay added on the Wi-Fi link than all of the other components that Barry was talking about. Because earlier, because as Barry mentioned, this is like a full ecosystem end-to-end solution, and problem that we're trying to drive improvements on. Wi-Fi is one piece. The access network's one piece. The core routing is one piece. How the game server's handling traffic and sending that data back to the user is another piece. And so, that's one of the reasons why Wi-Fi is so important, is because when it goes wrong, it goes really wrong, and you can get substantial latency spikes that's just from air contention inside the home and things of that sort.
Yeah,
we were testing this. We were actually pretty appalled at some of the 2-second spikes we were seeing within the test
no good.
We had just pretty traditional, busy household traffic patterns, right? It was I again opened my eyes.
Can I just speak for every game developer? All we want is, can I send packets 60 times a second and have them delivered a 60th second apart on the other side? It's all we need. And you know what? If you drop one or two, it's okay, right?
Yep.
And that's the use case. So I think the dual queue stuff is really cool. So Jacob, you actually wrote a paper about this. You presented this, including a lot of the results and the analysis. There's a public link for this, I think. So let's put the link up here. If you want to read Jacob's paper, take a look. I'm really proud that we were able to provide some awesome anonymized data that helped you guys find some interesting proof points around the dual queue stuff on a real live game in 2021.
I think
it's exciting.
I was just going to say too, like it's being able to partner, with and collaborate on research like this with folks like yourself, Glenn, is one of the things that we love doing at CableLabs, and it's one of the ways that we're able to be involved and stay kind of up to date on kind of what's happening in a variety of ecosystems and different industries and different use cases. And we've talked a lot about gaming here, but gaming is a very particular kind of high value user use case that we see on the network. And so, from our side, it was a pleasure being able to work with you and your team, and great to work with, and we're really happy with where the paper ended up. We got a lot of really great reception on the industry side, and so like you mentioned, we were able to share it at an industry conference a few weeks back in September, I guess a couple months ago. But we'll provide the link, and if any of the game developers or anybody who's listening to the podcast, whether you're a developer or not, have any questions about kind of the technologies and the marketing and stuff like that, feel free to reach out, and we'll be. If we're not the people to kind of get an answer for you, we'll be more than happy to try to find that person.
So we'll put up Jacob and Barry. If you want to contact Jacob and Barry, their email addresses are on the screen now.
Yeah,
reach out.
We're very interested in getting feedback, and to be honest, on an ongoing basis, we look at what the next generation of applications are, what their needs are, and trying to help understand whether it's cloud gaming or other real-time aspects of gaming. We don't want those. I always shudder to think of those Netflix spinning balls that we got when we started streaming video. And what we don't want to do is that, as we keep moving. I think a lot of application developers think of when they think of the network, they think of something they've got to figure out how to get around it, as opposed to let's work with these guys and make sure that our applications perform best on it. So
absolutely.
That's what we're really trying to
do. It's any game developer watching this, make sure you tag your packets. And if you're interested in how to do that, this is my email. Reach out and ask me, and I'll help you out. And we've got some open source code that should serve as code samples for that. And I think, Jacob, as well, there's some sort of support on the Xbox that does this by default. These days as well, that you guys have been working on.
Yeah, so again, we started evangelizing this to the game community 3.5 years ago, and including Glenn, and Microsoft actually
do it these days.
Yeah, Microsoft. Yeah, the Xbox now actually has it enabled if the game uses the preferred multiplayer port, then the user can turn this on. There's in advanced settings, there's turnings on. So. There's a number of games.
I believe that the Zoom has been tagging packets now for many years.
Yes.
So there's a use case for it's out there, it works, it doesn't screw stuff up.
Yeah, Discord does some tagging as well, and so one of the things we did was we the video collaboration guys. Of course, that's was important as well. So I mean, this has been around for a while. Most APs do pretty well. Not all, actually. Some of the worst APs we saw were gaming APs when we looked at them.
Let's stick with the high quality stuff here. So packet tagging. Check out Jacob's paper and feel free to reach out to Barry and Jacob and ask any questions. Hey, 10 or 20 years, we might have a gigabit up and down to play with. This is exciting, right? Thank you for helping us out with this. And everybody back home watching this, reach out to these guys. These are good folks, and they really are helping and working every day to make the internet better. Thanks, everybody. Cheers.
Here's the hard truth. The internet doesn't care about your game. After all the blood, sweat and tears you put into making your game, you launch, and some players get terrible network performance. What can you do about it? Build your own internet? This is why we created Network Next. Network Next is a radically new way of linking networks together. It's a new internet. One where networks compete on a neutral marketplace to carry your game's traffic. Network Next puts you, the game developer, in control of the network. We monitor every player's network performance and you choose when to accelerate them. Not only will you see better network performance for your players, you'll also have the security of knowing that if one network is congested, we switch to another in seconds. Now you control the network.